Let's begin with a little review of where we left off, because we kind of have to remember everything very carefully from where we left off in order to continue on with what you have right now. So just remember from yesterday that you guys learned that something to the 1/2 power, any base to the 1/2 power, was the same as a square root. Right? So turns out this new thing, this 1/2 power, is not something new. It's just a new way of writing it, not a new way of calculating it. So same thing here. So we can solve any of these just by doing order of operations. Exponents first, right? So figure out what the exponents equal. 7 and 2, and then do add, subtract, multiply, divide in the same order. So 7 minus 2 is equal to 5, right? So in the same thing applied for 1/3 power. That would just mean it's a third root. Okay? A 1/4 power just mean a fourth root. So we know that the third root of 64 is 4. 4 times 4 times 4 is 64. And we can do 10 here. So 4 minus 10 just equals 6. Okay, so this is just what we did yesterday. Then we crawled down here and said same thing, the order of operations. So do the parentheses first, then the exponents, right? And multiply, divide, then add, subtract. So it's important we do the parentheses first and then the exponents. So simplify what's inside the parentheses first. So what is 9 to the 1/2 power? Right? You get 3 because that's just the square root. Then do the exponent. Right? So 3 to the 3rd power is 27 because 3 times 3 times 3 equals 27. Okay? So that is really where we're going to start taking off from. Okay, so just keep to what we already know and add in what we are doing that's kind of new. So 16 to 1/2 power is 4, and then do the exponent on the outside. So it's very important in this order that you understand this, and we keep doing that today. Alright, so we're going to start off with something like this, but as you can see, there's a number on top and there's a number on bottom. How do we do that? Okay, so we could have easily just taken these two things, right, and multiply them, and 16 to the 3/2, because 1/2 times 3 is 3/2. So the actual answer to this is 64. We just had already broken up. So what you're seeing right here is really the second step of all the problems that you're going to do first right now. You want to turn them into something that looks like this to simplify it, but you're just given this. So if I give you 3/2, can you break that up into 1/2 and 3? Just basically take out the 3 and leave a 1/2 on the inside and have a 3 on the outside. Okay, so let's give that a try. There we go. Nope, that's not it either. There it is. So, for instance, here, if I give you 4 to the 3/2, go ahead and break that up in 2. Take the 3 out and put it up there, and then leave it as a 1/2 on the inside. So we're going to have 4 to the 1/2, 2 to the 3rd power. I did that. Just taking the numerator out, because they do different things. You might be thinking, oh, I got to figure out what the 0.5 or the 3/2 power is. That's 1.5. But really, they're two different operations. The number on the top and the number on the bottom are completely different. Okay? So we have 4 to the 1/2, which is 2, right? And then we have to the 3rd power, which is 8. So really, the number on the top and the number on the bottom are two different steps. You never combine them. You're not going to find out what the decimal is. You're not going to find out what 5 divided by 4 is and try to raise it to that power. You're going to just do them one at a time. Denominator first, and then raise it to whatever the numerator is. So we'll have 16 to the 1/4, right? And then raise whatever you get on that answer, raise that to the 5th power. Breaking it up into smaller pieces. So what is 16 to the 1/4, or what is the 4th root of 16? prefer, you can always rewrite it this way. This is the same thing, 4 through 16. You don't have to. Okay. They're asking the same question. What times itself 4 times equals 16? What do you come up with? 2. Yeah, 2 times 2 times 2 times 2 is 16. So the fourth root of 16 equals 2, or 16 to the 1/4, same thing, equals 2. And then you just have to figure out what's 2 to the 5th. Right, well, 2 to the 4th is 16. 2 to the 5th will be 16 times 2, which does 32. Okay, so you see that process, how we separate the numerator, denominator, and do 2 different steps. So that's the first part of completing these. So with that information, you should be able to go ahead and complete 1 through 7. Go ahead and complete 1 through 7. Stop on there. Give that a go. Let's take a look at these. Just going to go over, if you got 88 for number 5 and 126 for number 6, then you are correct. Okay. And you probably got all the other ones right too, because these include everything in the other problems. 6. Okay. So look at 6. We'll have first to do the square root of 25 because it's over 2. Alright. Square root of 25 equals 5. So we have 5 to the 3rd, which is 125. 5 times 5 times 5. And then with a base of 1, often the answer is just 1 because the square root of 1 is 1. And the square of 1 is 1, so you just end up with, and we could go through all the steps, but largely unnecessary. Yeah, the 5th root of 1 is just 1, and 1 to the 2nd is 1. And then lastly, we have to add them together, adding all these up. That's how we get 126. Good. So the next thing I want to do is look at the negative. That's why I have you stop here. What about negative exponents? So let's go back and review what negative exponents are. Okay, so up here, let's review what the negative exponents are. So let's, and I told you at some point that you want to be able to do this like on a test or a quiz, just be able to show why negative exponents are the answer that they are. That way you don't have to worry about memorizing, okay? But you will understand. So start off with something basic, something that you can solve easily, like 2 to the 3rd, which equals 8. And then start counting down, right? So 2 to the 2nd, we know, is 2 times 2, which equals 4. And you can start seeing a pattern. This is going down by 1. From 3 to 3 minus 1 is 2. And this is dividing by our base, which is 2. All right? So we can continue this pattern, right? And we'll get 2 to the 1. Right? Go down by 1 here, and then divide by 2 here. 4 divided by 2 is 2. So we know 2 to the 1 equals 2. And then continue the pattern. Go down by 1, 0. Divide by 2, and you get an answer of 1. So we know anything to the 0 power equals 1. This is how you could show by example and prove something is to the 0 power equals 1 as opposed to equal 0 because, well, there's a 0 here. So I'm just going to think of it and say 0. Mathematically, it doesn't make sense. And then we can continue this and go down to negatives and just continue the pattern and not change a thing on this side either. 1 divided by 2 is 1 over 2, a positive number. That was a big idea when we did this before. If you have negative exponents, it's a positive answer, right? It's a reciprocal. It's not a negative number. And we can keep on going and say, okay, 2 to the negative 2, and divide half into 2, and you get quarters. Right? Take $half, divide it into 2, you have 2 quarters. 1 quarter. And then we notice finally at the very end there's kind of a pattern here, right? If you write 2 as a fraction, that's 2 over 1. So 2 to the positive 1 equals 2 over 1. 2 to the negative 1 was 1 over 2. 2 to the positive 2 is 4 over 1. And 2 to the negative 2 equals 1 over 4. So the negative is really not a negative number. That's the funky thing here. A negative exponent is not a negative number. It's a reciprocal. So anytime you have a negative in an exponent, right, we're used to thinking of like negative 4 and then something like this, 2 negative 4. And you're thinking, well, this negative is the same as this negative. And unfortunately, they didn't get creative and come up with a new symbol here for negative exponents that you could easily say, oh, that means reciprocal and not mix it up with this negative. But they didn't. So you have a symbol that you're very used to meaning one thing, a negative number, but with exponents it means something else. It means positive fraction. Right? Negative 4 just means that's negative 4. But 2 to the negative 4 is actually 1 over positive 2 to the 4th power. No negative answer at all. It's 1/16. So just keep that in mind when we're getting ready to do these, that you don't have a bunch of negative answers out of nowhere. You should have a bunch of fractions. Negative exponents are fractions. Going back here, look at this number 8 closely. So now we have 3 things. This exponent actually has, well, this one has 2 steps because our top one is a 1, but we have a negative here. So the first thing you want to do is take care of that negative. Okay, so make it a positive by making the reciprocal. So we're going to do 1 over 81, so the positive 1/2, right? And if you're able to just get the answer there, you can do that, right? So say 81 to the 1/2 equals 9. But if you want to, you could also say, well, that's going to be the same thing as square root of 81, and square root of 81 equals 9. If you want to put in that step, that's fine. But if you just want to go from here to here, that's okay as well. Okay, so notice how the answer is positive 1/9. No negative answer. So a negative exponent, it's not the negative you're used to. It means fraction or means reciprocal in dealing with exponents. Okay. Let's go down to number 10. So this has 3 steps. Okay, you have the negative that does one thing. Okay, you have the over 2, which means that means square root, and you have the 5, which means raise everything to the 5th power. So there's 3 different steps here, and that's the real core of what we're doing today, is being able to look at this exponent and dissect it into 3 different steps in order. So step 1, take care of the negative by making a reciprocal. Step 2, take care of the denominator by taking it to that root. Okay? And step 3, raise whatever you have left over to that power. Okay? So again, a negative just means reciprocal. Okay? The denominator means take it to that root. Okay? Square root, 3rd root, 4th root, 5th root. And the numerator, the top number, just means take it to that power. Raise it to that power, raise the exponent. And you want to go in that order. Okay? We're just going to go through one of these, breaking it down in that order. We'll do a few of them. So we have a negative, so I see that. So the first step, take care of the negative by making it a reciprocal. So I'm going to do that first. So it's 1 over positive 5/2. If there's a negative, of course, if there's no negative, you just go to, what we have been doing and do the denominator first. So next, let's do denominator first. Next, so we can break it up into 4 to the 1/2, right? And then to the 3rd power. So in a sense, I'm just taking that 5 outside, right? Taking a 1 and just breaking it up into 2 steps. So now we know 4 to the 1/2, right? That equals square root of 4, which is 2. the last step is to do whatever that power is. In this case, raise it to the fifth power. 2 to the fifth power equals 2 times 2 times 2 times 2 times 32. And you get 32. So you see your answer is positive 1 over 32. Like I said before, you're probably not going to be able to just look at this and say, oh, that's 1 over 32. You're going to have to break it down, show all the work, and show all the steps. It's not going to be obvious just by looking at it. Okay, so just go in that order, and it'll probably work out. Show all the work, and it'll probably work out. Okay, let's do one more, and I'll let you guys try some more on your own. 81 to the negative 3 over 4. So I got 3 steps. I got reciprocal. I got to take the 4th root of 81. So I got to figure out what times what times what times what equals 81. And then I got to take that answer and raise it all to the 3rd power. So have a little plan ahead of time. So first the reciprocal, because it's a negative. 1 over 81 to the positive 3/4. Break it up. We're going to do 81 to the 1/4, and then raise that answer to the 3rd power. Okay. Figure out what is 81 to the 1/4, or what is the 4th root of 81. Same thing. Optional step is to actually write it in root form. You can write it like this if you like, and raise that to the 3rd power if that helps. Okay, it's the same thing. So the 4th root of 81 is 3. 3 times 3 times 3 times 3 is 81. Right? And then lastly, 3 to the 3rd power is 27. So our final answer is 1 over 27, a positive number. All right, so using that information, go ahead and work on the rest of the front. Okay, so let's look at number 13. So this has everything, plus at the very end you have to add a few fractions together. So let's review that, just to make sure we have it. So first we have a couple negatives, so we have 2 fractions. 1 over 8 to the 2/3. And 1 over 27 to the 2/3 as well. All right, so we can break those up into 2 cube roots. So we have 8 to the 1/3, and then square it. 27 to the 1/3, and then square it. So we have the 3rd root of 8 is 2. And the 3rd root of 27 is 3. Yeah. So far, so good. So we have 1/4 plus 1/9. And how do you add those fractions together? Through common denominator. So what's the smallest number that both 4 and 9 go into? And you'll get 36. So we have to multiply 4 top and bottom here. That'll give us 36, right? So we have 1 times 4 on top. And here we have to multiply top and bottom by 9 to get 36. So on top, 9 times 1 is 9. And therefore, our final answer is going to be 9 plus 4 is 13 over 36. There you go. So now for your purposes on showing algebra work, I only need to see this part here. And then if you know how to just look at, 1 over 4 plus 1 over 9 and get 13 over 36, I don't need to see all this elementary school arithmetic here. So that's fine if you want to put in a calculator and but write the answer as a fraction. You cannot just Don't make 1/4, equal to 0.25 and 1/9 equal to 0.11 and start adding decimals. Keep them as fractions. So if the question is originally in fractions, your answer should be a fraction as well. Okay. But there's other shortcuts on how to do this. So if you know them, you can just use those. Okay. All right. So that's our for the front. That's pretty much all you need. If you got this one right, chances are you got them all the others right as well. But if not, if you're not finished, keep on working on it, checking them. But let's move on to part 2. Just on the back, which is the kind of like the reverse direction of what you've already done. So on the previous problems, right? On all the previous problems you've had, you were given something like this, x to the 1/3, or 3 to the 1/3. No, sorry, not 3, but like 27 to the 1/3, and you converted those to cube roots. So you would say that's the cube root of x. This is the cube root of 27, and then if it was numbers only, you could get an answer. If it was just variables, then you were finished. So here, we're actually going to go the other direction. If you're given a cube root, right, write it as a fractional exponent and simplify. So cube root, something like this, you can rewrite this cube root as something to the 1/3 power. So take the cube root and rewrite it as the 1/3 power. Right. Then we can simplify. 9 times a third is 3. A third of 9, or 9 divided by 3, however we want to say it. Okay. So we can simplify. With variables, you use more of this work. So you notice on the front was all numbers. It was all arithmetic, no variables. So you use a lot of the steps we just did. On the other side, when you have numbers only, but when you have lots of variables, you end up using this direction as well. So, and later on, down towards the bottom of the paper, you're using both. You're mixing everything all together, including all the rules we've been using since last week. So it's a lot of rules that we start mixing all together. So once again, please show all your work. Do not take shortcuts and just stare at it, and I'll just look at it without showing anything at all. Okay, write it out. So 1/5, the fifth root is the same as the 1/5 power, and then you can just multiply them together. All right, 15 times 1/5 is 3. Right. If you really wanted to, you could write it as m to the third, n to the third. Well, the thing is with these problems is that there's actually lots of ways of doing them. Once you get used to all the rules, you're going to know shortcuts. You're going to know multiple correct ways of doing it and getting the right answer, the same right answer. So I'll leave it to you to find out, different pathways. So just know as you're working on these and checking with people, if your work is kind of different but you're coming out with the same answer, it's probably okay. And you might do it one way and then see somebody else do it another way and like, oh, I like your method better, and start using that method. But the important thing is for you to figure that out on your own and discover those on your own. I don't like just to give you, here's all the shortcuts, here's all the steps, because then it gets confusing. And then you never learn how to show all the work on it, so you're never quite sure if your shortcut's right or wrong because you can't verify it with showing work. Okay, so let's see here. Let's do number 3. You can see there's a little more work here. So you can do a couple different paths. You could simplify everything in here, right? Let's simplify everything on the inside. So what is 8x to the third, right? Times 8x to the third. That's what this means right here, 8x to the third squared. So your answer would be 64x to the 6th, right? Because remember, you add exponents when you're multiplying, so we're using more rules from the previous lessons. 3 plus 3 is 6. And then you can do what's the cube root of 64x to the 6th. So what times itself 3 times is 64, right? And what times itself 3 times is x to the 6th. Okay? Or if you prefer, you could write it as 64, right? X to the 6th, and rewrite this to the 1/3 power. Okay, so lots of different ways of going about these, which could be nice because, oh, there's lots of ways, but another way it can be kind of confusing because, like, wait, there's so many things I can do and I'm not sure which way to start. So let's try one, see if it works. If it doesn't, try something else. So what's the 3rd root of 64? You get 4. And then you could do 6 times the 3rd and get 6 times the 3rd is 2. Right? Right? Now, if you can just look at this right here and get 4x to the 2nd, you can do that as well. You might say, oh yeah, the 3rd root of 64 is 4. 6 divided by 3 is 2, and that's a little faster. So you're going to see some different methods. Okay? Another method, you don't have to have both of these, but another method is just to, from the very beginning, go ahead and make it to the 1/3 power. Right? And I'll show you a little trick. Because of commutative property, it doesn't matter which order we multiply by, right? So a little trick we can use would be to do this. Is noticing that this 3, this 3 right here and this 1/3 are very compatible. 3 divided by 3 is 1. And that you can take the 3rd root of 8, so why not just switch the order around? Make it like this, to the 1/3. And then, lastly, raise everything to the 2nd power. Right? So you can do 8, the cube root of 8, or 8 to the 1/3, and get 2. The 3 divided by 3 would give you 1, right? And then you could square that, and that would give you 4x to the 2nd. So 2 somewhat completely different ways of doing the problem using algebra, and you get the same answer. And there's actually a 3rd way you could probably go about this as well. And you'll just figure those out, and you'll see that as you're doing that. So if you get this feeling like, wait a minute, I wonder if I could just do it this way, try it. While everybody else does another method, you'll try this method, and if you guys get the same answer, you've just discovered on your own, oh yeah, that works too. And the more you discover on your own, the more comfortable you're going to feel with this, because you'll get some confidence there. All right, so go ahead and try number 4. Okay, give number 4 a shot, see using different methods, and see how it goes. Okay, so let's take a look at 2 ways of doing this, and it's going to be similar to the 2 methods I already have up here. Okay, so watch up here. So first method is to actually simplify what's in the inside the radical here, just like I did on this one. I got 64x to the 6 by simplifying this part. So let's do that method. All right, so we'll get the cube root of, now you had to do 27 times 27 times 27 times, 4 times. So you got 500,000, I think 31, 441, x to the 12th, right? And then you had to figure out what's the 3rd root of this, which you could really only do with a calculator. At that point, you really stuck to the calculator. So the 3rd root of this big number came out to be 81. 81 times 81 times 81 is this number. And then you could do 12 divided by 3, which is 4. Okay? So there's one way of getting the correct answer. Another way, though, is to do the second method, right? So we're going to have 27 x to the 3rd to the 4th power, and then raise everything to the 1/3 power, right? And then switch the order here, okay? Make that 27 x to the 3rd, Also, to the third power, all to the fourth power. Alright? Now, you can do the cube root of 27x to the third. The cube root of 27 is 3. 3 times 1/3 is 3x. And then 3x times 3x times 3x times 3x. That'll give you the 81x to the fourth. And you don't have to use a calculator here, and you get the same answer. The two methods get you the same thing. We'll finish up the rest tomorrow in class, then maybe take a little quiz at the end.